everyone, and welcome to our second of 5 webinars on managing nature's resources and organic production under water-limited conditions. Today's webinar is on soil organic matter. Nature's sponge helps crops access water and nutrients under drought conditions. So I'm Karen Clausen. I'm from the Manitoba Organic Alliance. We host the series of webinars with our partners over at the University of Manitoba, the Natural Systems Agriculture Group. You can find more about us on our website at manitobaorganicalliance.com. So we are able to host these webinars because of generous contributions from our sponsors. So we are sponsored by FCC, Grain Millers, Manitoba Harvest, ProCert, and Theory Mesh. We also receive grants and funding from the Prairie Organic Development Fund, the Government of Manitoba, and the Canadian Agricultural Partnership. So today's host, I'm going to just move you over to our host, Dr. Martin Enns, who's from the University of Manitoba.
Okay, thanks, Karen. I'm assuming you can hear me. Good afternoon, everyone. Good morning, good evening, wherever you are. I think for most of us, it's 12 noon. So welcome. And welcome to you, Laura Van Eerd. Thank you so much for joining us today, away from Ontario.
My pleasure.
And then I'm going to ask her a few questions, just sort of some folksy questions. But Laura Van Eerd is a professor of sustainable soil management at the University of Guelph, Ridgetown campus. And if you're not familiar with, that's in southwestern Ontario. And the goal of her program is to understand the cycling of nitrogen and carbon in cropping systems, in various agroecosystems. Dr. Van Eerd's interests are in looking at cover crops and other management steps that can be taken to improve soil health. She's done a lot of work in that area. She has also done a lot of work on nitrogen use efficiency. And Laura works not only on field crops, but also on horticultural crops, so crops that are probably a bit more sensitive to some things. And she also is an active participant in Ontario's long-term studies, which have helped her understand the role of soil organic matter in water-smart farming systems. So Laura has excellent practical knowledge. She does a lot of work with farmers in her region, and she's won awards in teaching and was recently recognized as one of the 6 influential women of Canadian agriculture. So, hey, that's cool. Congratulations, Laura.
Thank you.
And welcome. Welcome. How are you today? And what's the weather like where you are?
I'm great, and the weather's even better. It's like in about 15 degrees. It's nice, beautiful weather for collecting cover crop biomass, which is what the rest of my crew is doing today. So we've had a really long, open fall. It's been wet, but hopefully without any rain, the farmers are going with harvesting.
Oh, what are they harvesting now?
There's still some corn out just because we've had a really wet fall. So they're wrapping up harvest.
Okay, okay. So, Laura, can you tell us a bit about what you do at the University of Guelph?
Yeah, I'm a professor of sustainable soil management. So I'm interested in, just as you described, what can farmers do on their field that benefits their soil and benefits crop productivity? So some of that work is looking at cover crops, looking at nitrogen use efficiency, different technologies to enhance nitrogen use, and both in horticultural, so processing veg. We still have a decent processing vegetable industry here in Kent County. And then also in cash crops, corn, soybeans, wheat.
And do you also teach?
Oh yes,
And if so,
that's
what
my
do you?
research program. Yes, I teach. I teach in the environmental management program here at Richtown campus, and I teach organic production in the ag program. So I get a really great opportunity to interact with students about the issues that farmers are facing right now.
Okay. So what are some of the, like, your organic crop production students? Why are they taking the course? Is it a need to take course, or they're kind of interested in looking at this production system?
It's an elective course, so there's all ranges of interests from I'm skeptical, but I want to take a crops course, to our families growing vegetables and we're thinking about organic, to they're already in it, they're doing small market, trying to make it work organic. So all ranges of students. Most, if not all, are from the farm in that course or farm market.
Okay, that's great. That's great. Well, I would have to say that the same is kind of true for the organic students in Manitoba in the course that I teach, and it's really interesting that it's an elective course in both of our universities, but there are students taking it. And I guess for the audience, that means that they don't have to take the course. They can take it if they wish. And so that's interesting. Let's turn our attention to drought. And, we were talking before the webinar that we've had, the driest year on record. And so, tell us a bit about the droughts that you've faced in your part of the world. Because we often think of Ontario as really wet, and you just said you had a wet fall, but we know that you run into water shortages as well. So, tell us a few of your thoughts or experiences with, water limited agriculture.
Yeah, I mean, relatively speaking, yes, we definitely have more rainfall. So during the year, we get about 3 inches of rain per month. And so you can compare that to your region, but 3 inches per month isn't enough to feed the crop with rain. So evapotranspiration is greater than the amount of rainfall, and it's greater by 2 inches. We have a deficit in July and August. Now, some years it's more than others. This past year, we had pretty timely rains. We had really timely rains, actually. And some regions had far too much moisture. And I mean, on a soil that's already saturated, another 9 inches was the scenario just 50 kilometers from here. And that extreme, the soil can't handle it, right? And the same with drought. There is limitations to how much can be overcome.
Right. So, all right, I guess we could probably just pack in the seminar right here and just say, there's really not much we can do. So, but we do think that if we look at our soils, there are some options. So, yes. Maybe just turn it over to your, give you the opportunity to share your presentation that you prepared on this subject, unless you'd like to add something before you get going. But thank you so much for my folksy little interview.
There you go.
Is there anything you'd like to share before you get going with your presentation?
No, I think that's it. There's definitely things we can do to improve soil. There's no doubt about it. Are there magic bullets? No. Does it require dedication and commitment? Yes. Can you see those changes? Absolutely. And I guess that's my approach to this talk is kind of outline what our research has been showing, give you some timelines on that, and some strategies that could work in your system. And so hopefully growers or whoever on this talk can take what we're seeing in our research trial and apply it to their system.
Okay, that's great. We're looking forward to it. And I'm going to sign off in a minute. I just want the organizer to know I did get a question. It said, can everyone else hear the seminar? Maybe that means that one person can't hear it, but I'm assuming everybody can hear it because we've only heard from one person. Maybe they had startup problems. So Laura, we'll see you on the other side to pick up the discussion.
You can see my
and
slides.
to enter questions. Oh yeah, slides coming through loud and clear. So is your voice. See you later.
Great. All right. Thanks, Martin. All right. So the talk is organic matter, nature's sponge. I think that's a great title. If we think about it in terms of nutrients and water. And so what's the value of that sponge, of that organic matter? And it's really difficult to put a number on it, but we know it when we see it. So if you've got compacted or low organic matter, you're going to have, ponding, less infiltration, and it's hard to get wet again. With healthy soil, with good organic matter, you have nice infiltration, supplying that crop water and nutrients. And I've got some other ways of valuing nature's sponge. Is it, what is the value of a timely rain? Or having less standing water that it drains? Or what would the value have been in having 5 extra days without severe drought stress? Would have that carried your crop through or provided that extra 20 bushels? I think those are really tough questions. And I'm hoping that we'll get to it in terms of the value of organic matter as a sponge. I love showing this photo of John Burke. I met John about a decade ago. He is a farmer in Michigan, so relatively large acreage in Michigan. He's got good crop rotation that includes winter wheat, no-till, and cover crops. And we had the good fortune of having dinner together at a Midwest Cover Crop Council meeting. There we were talking about his system, and he said, I've seen increases in organic matter. We've done the soil testing. We've seen the organic matter go up by 0.5 to 1%. And so the conversation went in many directions, and one was about the value of soil testing and measuring soil organic matter. The other one was, hey, John, what are you seeing in your field, though? What does that mean? And he said 3 things. He said, I'm pulling bigger equipment with less horsepower. So that's easier to work land. Says when we get those big rains in the summertime, there's less ponding, great infiltration. And the final thing he said was in 2012, when things were really dry in his region, he pulled off good soybean yields, on average 55 bushel in 1,000 acres. So he's like, things aren't bad. And that's the value of soil organic matter, is that resiliency. I really enjoy this picture because I think it summarizes quite a bit. So this is from colleagues of mine, Charlotte Norris and Kate Congreaves, where they put this schematic together that if you have shallow, compacted, low organic matter soil, you're going to need to put in a lot of inputs, whether that's water, whether it's nutrients, maybe pest control. But by figuring out those puzzle pieces to improve soil health, the goal is a more healthy soil is less reliant on those inputs, because the soil, the organic matter, nature's sponge is providing it to your crop. And so what I hope to do today is talk about what are some of those puzzle pieces that might work on your farm, in your system. So to do that, if we're going to talk about organic matter, we need to be thinking about long-term experiments. It doesn't take 25 years, it doesn't take 40 years, but we have those experiments here in Ontario. So in 2020, we celebrated 40 and 25 years of the Elora research station and at Richtown. Here we have long-term experiments comparing different cropping systems. So Elora is a silty loam with 2,700 corn heat units. Richtown, where I am located, it's a clay loam and it's 3,300 corn heat units. So let's have a look at these trials. So at Elora, on, again, a silty loam, we have 8 crop rotations. So continuous corn, continuous alfalfa, and then 2 years corn, 2 years alfalfa, or 2 years corn, 2 years soybeans. And then we look at what's the impact of adding small grains to the rotation. So corn, soybean, wheat, with and without red clover, or oats, barley, and the mixture with red clover. This 4 replicate experiment has 2 tillage systems of fall moldboard plowed, and that's compared to no-till. Oh, whoa. Ugh, isn't that funny? Well, that just hit the wrong button. There you go. Quick review. Here we go at Richtown. Richtown has a different crop rotation. It's continuous corn, continuous soybeans. The dominant rotation now in southwestern Ontario of corn, soybeans, adding small grains to the rotation with and without red clover. So this is winter wheat. And then we have the mixture of soybeans and wheat, winter wheat, with and without red clover. This is a really nice system because now we can look at the frequency of adding small grains into the rotation, where it's every 2 years, every 3 years, or not at all. Corn has 4 different rates of nitrogen, same with winter wheat, and 2 tillage system, moldboard plow, no-till, and then the corn is strip tilled just to get better seed to soil contact with the strip tillage. I'll take a moment to show this aerial photograph, which was taken in August. So you can see the wheat was harvested and the red clover seeded. Have a look. This is the corn. With winter wheat in the rotation, you're less reliant on nitrogen inputs compared to right here. Without winter wheat in the rotation, you're seeing that low nitrogen rates. So the winter wheat in the rotation is providing some resiliency, and we'll have a look at the numbers. So to celebrate these 25 and 40 years, we collaborated at Soils at Guelph with the Ontario Agri-Food Innovation Alliance to create a bunch of infographics. And you can find those infographics here as crop rotation counts. So these infographics, they're summarizing a lot of research. And in terms of soil health, soil quality, increases in soil organic carbon, increases in total nitrogen, soil organic matter. What we're seeing in like half a dozen different independent studies is the value of small grains, red clover, and alfalfa in the rotation. Winter wheat increases soil organic matter, so does red clover, so does alfalfa. So what's the value? What does that greater organic matter give? Well, on average, 15% more corn yield and 13% more bean yield. That's quite huge. If you think that that's an average over 10 years, it's large increases in crop yield. What else do we see? We see reduced risk of low yields. So those are the extreme weather events such as drought or excessive moisture. That added organic matter is protecting from those extreme years. And we can relate crop yields to soil organic matter. So here we have soil organic carbon, and we see average corn yields. This is a 5-year average. The greater the soil organic matter, greater the yields. And maybe more importantly is this variation in yields. So this is the standard deviation of over those 5 years. We're seeing that more soil organic carbon, less variation between years. So those drought years have less of an impact. And here visually in an infographic, we can see this. So stable annual yields. The other thing that we've seen, especially at Richtown where they have different nitrogen rates, is that you need less nitrogen fertilizer. Why would you need less nitrogen fertilizer? Well, you're getting it from the soil organic matter. The organic matter is cycling and releasing nitrogen to the crop. And we can see that really nicely here. So this is work done at Richtown, where you needed 17 to 21% less nitrogen fertilizer by having winter wheat in the rotation. So that's the long-term impact of winter wheat because it's increased organic matter. So here's the data. We have nitrogen rate on the x-axis and corn yields. So here are the different crop rotations. I put arrows kind of indicating where the curve flattens out. And so your most economical rate is approximately here. So that's the value of the long-term increases in organic matter from winter wheat. You need less nitrogen. This is true in the plow system as well as in the zone till. So there, right? If you're continuous corn, you need more nitrogen. Part of it is residue breakdown of the corn, but also it's the value of organic matter, releasing nitrogen to your corn crop. And you can see it. You can see it. These are side-by-side plots here with winter wheat in the rotation. Both of these photographs were taken on the same day. May 3rd, farmers would be ready, ideally ready to plant. But with less organic matter, you have ponding, poorer soil structure, not as dark. This is at Richtown after 24 years of winter wheat in the rotation compared to without. And this translates to 4 to 6 bushels of soybean yield or 6 to 17 bushels of corn. This is a 10-year average. This is huge. So how does this work? We have continuous living plants with alfalfa, we have cover crops, and then we have complexity with our crop rotation. So how are you going to build soil organic matter? Well, the first goal is to protect the soil. You want to minimize soil disturbance, maximize soil cover. So let's take our highlighter. If we've got a cover crop, yes, we're maximizing soil cover. How about building organic matter with diversity and adding perennials to the mixture? Cover crops, yes. Small grains, continuous alfalfa. Great. Diversity with the crop rotation. Yes. And then think about building soil carbon. So how are you going to build soil carbon? That's about leaving crop residues, having plants growing all the time with your continuous living plants such as alfalfa or cover crops. So if you're going to build soil carbon, you want to think about also minimizing the losses, minimizing erosion. Well, keeping the soil covered with alfalfa or cover crops. This is kind of your score sheet. I think when you're designing your system, if you can think about this as your score sheet, all right, what can I do to protect the soil? What can I do to increase diversity or add perennials to the system? And how can I build carbon? And that could be adding manure, or it could be growing plants. And in the long-term trials that we just talked about, yep, they're checking the boxes. Okay, so that was 2 long-term trials we have in Ontario. We also have a different long-term experiment, which is looking at cover crops. So this experiment was established in 2007. We have 14 years now of cover crop production where we have 5 cover crop treatments. They're side by side. We have the no cover crop, oats, radish, cereal rye, and a mix of rye and radish. This site is on a sandy loam soil. So this is, or a loamy sand. It is very representative of the processing veg industry we have in southwestern Ontario, and that's the crop rotation. So what do we do with this long-term cover crop experiment? So after we harvest our main crop, we'll plant cover crops. We use a drill. Cover crops are left to grow over the autumn into winter. In the spring, we terminate the cover crops. We will incorporate residues. So we'll do disking and cultivating to incorporate the cover crop residues. And then we plant the main crop. After main crop harvest, we're going to till again and then plant the cover crops. And so here's our rotation. The main crops change, the cover crops are in the same plot year after year. So in this experiment, we've we've looked at soil health. So here we've got a schematic of the rotation. So we have the processing veg, sweet corn, spring wheat, tomatoes, commercial corn, squash, soybeans, winter wheat, and then tomatoes. So this is pretty representative of a processing veg rotation. After harvesting the main crop, we were able to plant cover crops 6 times in 8 years. So relatively short time when we're talking about soil health. I had an excellent PhD student, Eerd Chahal, who looked at soil health in this experiment. And what she quantified was increases in soil health. It depended on the parameter, but up to 17% increases in soil health. Carbon stores were increased up to 22%. And when we look at other long-term experiments, we can see not that high, but we're in the same ballpark in terms of storing carbon, increasing organic matter. Now, what does that do to crop yields and profit margins? We were seeing over this 8-year rotation, crop yields were 4 to 11% greater, and profit margins 5 to 9% greater. This was dominated though by tomatoes in the rotation. Tomatoes were quite responsive to the cover crops, and a small increase in tomato yields can have a nice economic pay. In our system, you know, this is the average over the 8 years, but we have to keep in mind that it's mainly due to the processing tomatoes. So Eerd measured in 2015 and 16, she measured soil health increases. And then we had an opportunity to work with the Ontario Soil Health Institute. And they ran a North American-wide experiment sampling soil health at various long-term trials. And their data from the Soil Health Institute is showing exactly the same thing as what Eerd found a few years earlier. The cover crops are increasing soil organic matter, and 5%. So this is growing annual cover crops 9 times in 12 years at the time that this was sampled. So not a lifetime to make changes in organic matter, but it does require a dedicated focus on cover cropping. And, you know, we do have the soil moisture, we do have the long growing season to accumulate above ground and below ground biomass. So, you know, whether you'll see those increases in your system in that short of time, I'm not sure. But what I think we're seeing now is the value of those cover crops to the rotation, the value of that organic matter to the rotation. And here in 2020, here's a photo. I'm not sure on your screen if you can see it, but it was night and day, or light green deficient versus dark green and healthy. The no cover crops, that corn was looking for nitrogen. So in this case, this is in 2020, we grew annual cover crops 10 times in 13 years. We grew corn with only starter nitrogen, so that's 30 pounds up front. And we saw the corn respond. It was less tall, less green, where we had no cover crops in the system, compared to long-term cover cropping. We've got SPAD meter that confirms that measure in greenness. And so we watched this all season, that the no cover was shorter, and it actually turned into yield gains, and pretty substantial yield gains. So this is the average of 16 data points collected from these plots. So we saw a 60 bushels increase in corn yield. Now, this is a very productive ground, right? It's a light sandy loam. It's very forgiving. And we were dry. We were dry in the first part of the summer. And so what I think is happening, you can see it here, is that organic matter, with more organic matter, we had greater yields. So this is data from the Soil Health Institute. The higher percent organic matter, the greater the yields. So this is about that long-term cover cropping, the mineralization of nitrogen, providing it to the corn crop. And we know nitrogen and water go together, right? And in 2020, we were pretty dry. The soil, these months are below average. We didn't get a good rain until July 10th. And so soil moisture conditions were low. And so that combination of soil organic matter, of available water, release of nitrogen is what I think we're seeing here. So this was in 2020. We have a repeat of this experiment, and we saw the same thing in 2021. So this year, we're more normal or more abundant rainfall. We're seeing the same thing. So here are me standing in front of my plots. I had someone take a photo. This is actually two different photos that I lined up and sized accordingly. You know, use myself as a ruler. Same thing this year. The no cover crop looked less, well, it was hurting for nitrogen. It was more deficient, less tall, less green. And I had my graduate student grab a random sample to take, you know, the classic photo. We'll see. We don't have our yields yet this year. We're still processing corn. I'll be curious to see if we're seeing the same effect 2 years. So what do I think is happening? I think these cover crops are stabilizing soil organic matter. So there's 3 ways to stabilize organic matter. One is through physical production inside an aggregate. So you can see here, this is the nice sandy loam, and you see nice aggregates here. So when an aggregate forms, kind of traps away soil organic matter so that it can't leach away or microbes can't break it down. So we can have physical protection. This is great because the more organic matter you have, the more aggregates you get. More aggregates you get, the more organic matter you protect. And so it's a positive feedback loop. So this could be happening on our soil, but we are pretty sandy, and it's kind of difficult to build aggregates on a sandy soil. The other way we can stabilize organic matter is through chemical absorption to the, so it adsorbs to the mineral sand particles or mineral soil surfaces. And a nice schematic here. And that's our hypothesis, is that we have a lot adsorbing to mineral particles. And that's good. There's only so much you can do, right? You don't change your texture. What I think is the main driver in our experiments, and I think in other cover crop research, is that you have persistence of organic matter due to your biological activity. So that addition of plant residues and microbial residues, it enhances microbial communities. Those microbial communities, they release organic matter. They stabilize that organic matter. And I think this is what's happening in our experiment, and that's the next hypothesis we're looking at with the new graduate student starting this summer. So let's put it all together. Here are the processes, the practices that you can employ on your farm. We didn't talk about conservation tillage, but we know if conservation tillage can maximize cover, minimizes erosion losses. Doesn't mean that you'd have to eliminate tillage, but if we think about this as our score sheet, trying to minimize tillage is an effective way to build soil carbon. Minimizing compaction. We're back here to this puzzle piece. So which one of these 6 C's of sustainable management would work in your system? I would like to acknowledge funding partners. I'd like to acknowledge our team of researchers. And here's our current group, which is that's the state of things. So I'll stop it there, and thank you very much. Thank you to my team, and I look forward to our conversation and what questions you might have.
All right, that was just fantastic. I think some really inspiring data and very applicable to Manitoba and prairie agriculture, because we see that organic matter is good, and you demonstrated that really clearly. And what's really unique about your study is you actually attached some values in terms of yield stability and in terms of economic benefits, and that is not that, we don't see that very often. So congratulations on your work. Congratulations to your team. I'm going to ask for people to put their questions in the question box, because now we have about half an hour for discussion with Laura, and I think you probably have questions. And so I'm monitoring the question box, and I might have some help from the organizers here just in case I missed something. So questions are coming in. I have to say that the question box that I'm looking at is extremely small. If it can be made bigger. But here's a question. You ready, Laura?
Yep.
Could zero tillage not be used for some of the operations in the cover crop sort of research project or in the cover crop option? So I'm going to suggest that maybe, or like in systems, could some minimum till zero tillage be used in the cover crop part of that system?
Yes, and yeah, so we have 14 years. There are some years, depending on which crop we're going into, we definitely don't incorporate all of the crop residue. And so if we harvest soybeans and we're going to winter wheat, we definitely are no-till because that works well in that system. So the tillage part does vary based on the main crop and the amount of cover crop residues there. However, if we're transplanting tomatoes, we are definitely following current production practices and we are incorporating cover crop residues. I guess the thing, yes, we could do less tillage. Yes, we could do less. The interesting part though is that we are building soil organic matter even with relatively aggressive tillage. So that, in my mind, in this system suggests that it's having plants growing that's more important than any disruption that might have happened with the tillage. The other thing when we talk about tillage is that, you know, like most research sites, we're on flat ground and it's not susceptible to, like there's no slope, so less susceptible to water erosion. So that's one of the considerations when we consider tillage.
What about when you establish the cover crop? Like if you're taking a crop off, let's say if we're looking at an organic scenario on the prairies, let's say somebody's harvested oats and the oats are harvested quite early that year and there's, let's say they're harvested 25th of August and there's still time to grow a cover crop.
Yep.
Would you, could you see no-tilling a legume cover crop into there, like say peas or faba beans mixed with something else?
Absolutely, absolutely.
And do you want to comment on some of like your experiences in terms of kind of the machinery that might work or the, you know, the challenges and things that might present?
Yeah, yeah. So yeah, so it's all about management, isn't it? Like how much oat stubble is left, how evenly is it in the field. I guess my goal in planting a cover crop is to get good seed to soil contact. So if that means, and whatever equipment you have, I think whatever's time, cost, like however you can get it done is golden. I don't, there's no, I don't know. I guess I wouldn't hesitate in managing that crop residue. If you have to till it, I think that's fine because the goal is to get a cover crop in the ground and growing. And whatever can accelerate that is, in my opinion, the best approach. We have experiments going on right now that are looking at zone tillage. So 8 inches, 8 inches where the corn is going to be planted next year is tilled in the fall. So we're preparing the seed bed for the corn. We are trying bio-tillage, so using radish or a mixture of radish with oats, buckwheat, faba bean. And the concept there with bio-tillage is that those cover crops leave the seed bed in a nice condition the following spring. So they decompose relatively quickly. They have different root architecture so that it prepares the soil nicely for your next crop. Yeah, in my mind, it's all about good agronomy. Get those cover crops growing.
I like that answer. It's very practical. You have clearly a lot of experience. One of the other thoughts that crossed my mind is that sometimes if you called it managing the tillage, and so you meant tilling the soil and before seeding the cover crop, I guess. And you know, you do get a better establishment, and it might actually allow a warmer seedbed and things to come out of the ground a bit faster. I'm not seeing any questions. Well, I just saw the one, and I don't know if people are having trouble using the question thing. If you have a question, unmute yourself and ask it, please. Could you please do that? Just unmute yourself. Hopefully our administrator will allow you to do that and just ask your question. That'd be great.
Martin, I'm going to ask a question. It's Karen here until we have someone else asking questions. I was interested, just speaking of your radishes that you were talking about, it seemed like on most of those graphs, it was the radishes alone that were leading to higher yield, even more so than radishes in combination with other crops planted in a polyculture. Can you tell me why that is?
Yeah, I wish I could. Yeah, so I guess over the years that we've done this, it's not always radish that comes up ahead, right? And I wish it was, because then that would make an easy story, right? Just plant radish. But it's not always the top one. I would, so we've accumulated maybe 6 years of tomatoes, and with that database and what we've seen, I would recommend radish and rye because it's always in the top 1 or 2 in terms of yield. This is the first year we've seen commercial grain corn respond to our cover crops. I think it's because of the organic matter and nitrogen and water. And so until I see this year's results on corn, I'm not sure it's about just the radish. It does, though, tend to accumulate more organic matter. And I'm not sure if it's, yeah. Like when I look at the percent organic matter, it's 3.9 versus 3.7, and those aren't statistically different. So whether it's radish or rye, I guess right now I'm not ready to say go radish. I'm ready to say go cover crops, and then it is showing increases in organic matter.
Great, that's a great answer. That's a great question too. I just got an instruction from the administrator. If you want to ask a question, you have to raise your hand. So click the little hand thing, and the administrator will unmute you. Okay. So let's have a moment of silence to wait for people to do that.
And Martin, there's a question in the private box. It was accidentally sent there.
Go ahead, please. Articulate it, Laura.
I don't see it. Can you read it, Talise?
I cannot see the private one, no.
There was this one about could zero till not be used for some of the organized operations in the cover.
No, we already got that one. Thank you very much.
Okay, and there was another one.
I mean, there's I got it. Yeah. I got it about establishing under dry conditions. Maybe a real quick comment, Laura. If things are dry, are there any cover crops that you favor for dry planting over others?
I guess I would think about seed size and maybe go for a smaller seed size.
Right.
Yeah, I don't know of any studies that have looked at. Do you know, Martin?
Yeah, you know, one study that, so I think what Laura was talking about with seed sizes, if you plant something like radish or mustard, it's very small. It doesn't take a lot of water to germinate it. But if you plant a big crop, like big seed like peas, it takes a lot more water to get that thing to germinate. So
Yeah,
I agree. You know, there was one of the interesting things about cover crops is I remember a study that was done by Guy Lafond at the University of Saskatchewan when we were grad students there, is he looked at how much precipitation was actually required to get a winter wheat crop to germinate. And it just was much less than a spring wheat crop because, you know, the day length is shorter in early September. You get some dew, you know, DEW,
yeah.
on the ground. And all that really contributes. But I don't know of any real good study on that one.
So our approach. So when we have wheat harvest, it's, you know, end of July, early August, and we tend to be dry. My recommendation is in our province, in our region, is you can plant a cover crop when it's dry and when the moisture comes up. Like we are going to get rain, right? So you can plant dry and then wait for the rainfall. I'd prefer that you have your seed and everything ready, and then after it rains, you plant. But then we're still early August, right? So it's a different approach, and we always have recharge in the fall. Depends on when we get that recharge of soil moisture, but we do get it.
Okay, the questions are pouring in. I'm going to ask you a question, which is, I think, a pretty common question for you. But while you're thinking about it, I'm going to ask you another question. So the question is, if you're using rye as a cover crop, and let's say you want to grow spring oats the next year, like when do you terminate it? And the question that I want to ask, and you can answer these in any order you want, is what's going on with the comments now that tillage is not all bad for soil health? You know, you mentioned that, you know, like in the hierarchy of things that you talked about to improve soil health, it seems like tillage is not the biggest villain. And, you know, I think the audience would like to hear about that. So you can answer those two questions in whatever order you want.
Okay. So with rye, like my preference is, and I know it makes it complicated, but my preference would be to have that cover crop over winter so that you get the wind erosion protection, maybe you catch some snow on the cover crop. So my preference would be to terminate the rye in the spring. When to terminate in the spring is as soon as it's actively growing. That means it's greened up and it's actively growing. You need that. Plants need to be growing actively for the herbicide to work. And so as soon as you see it green up, then terminate.
What about in organic production?
Oh yeah, sorry.
What about in organic production?
Sorry, guys.
No worries, no problem. No, you know, there's
yeah.
no problem.
I don't have enough experience. And you know,
Okay.
there are people here that are doing the roller crimping of rye, and I can tell you when you have to target for roller crimping, but I'm not sure your season is long enough. That part is risky too. Still
No,
though, my preference.
I can jump here. I can jump here on the organic stuff. I think if my former technician Keith Bamford were on the call, he's retired now, but he would say in an organic system, you want to get rid of that rye at the same time that you suggested, Laura, as soon as it greens up, because it can become very difficult mechanically. And the nice thing about that is that we know that the allelopathic chemicals that rye produces to suppress broadleaf weeds like redroot pigweed and mustard and lamb's quarters, that's already being produced when the rye is in the 4-leaf stage. And so by terminating the rye with tillage in early spring, you are getting those allelopathic benefits. And of course, if you're going to seed spring oats in there, you want some time for the nitrogen to mineralize. You don't want the rye locking up all the nitrogen. So
Yeah, that was
okay. So that was easy. That was the easy question. Now, what about the answer to the other question? Is, you know, tillage is, like you made the point that, you know, if you can avoid tillage, reduce tillage, that's desirable. But what are you thinking now about the role of tillage in soil health?
So I think the data shows that in the 15-centimeter layer, there's greater soil organic matter and soil health in the no-till than in the moldboard plow. That's our data from 4 sites, long-term sites in Ontario. I think, yeah, so definitely no-till. The caveat is if you have a compacted soil, you need to get that fixed. And one tool in the toolbox is tillage at the right time. So, and then the other part about it is, from what I've seen with the cover crops and with the crop rotations, I'm more and more convinced that it's the plants. Having living plants, having that association with the soil microbes and stabilizing carbon with that plant soil microbe interaction is where we can have the most impact on our farmland.
Okay, so when you're teaching organic crop production then to the students at Ridgetown, you're telling them that if they are using tillage in their organic operations, that they should backfill that with a lot of plant diversity and a lot of live root days in their fields?
Yep. And then organic amendments is the other key builder.
Okay.
Yeah.
Okay, good. There was another question here, and that is, what are the future goals or changes you plan to make on your cover crop projects based on what you've learned?
Yeah, so our future goal, and I kind of alluded to it, is to try to figure out the mechanism of how the organic matter is accumulating. So is it being stabilized on the mineral surfaces, like chemically? Is it a physical, like, is it stored in aggregates? Or is it that microbial plant soil interaction where the microbes are stabilizing it. And so we're collaborating with Dr. Carrie Dunfield, and she has a graduate student who's sampling microbial communities, looking at microbial function and the cycling of nitrogen. The other thing we're testing is kind of the cycling of nitrogen to that corn crop. And I don't know if so we're interested in testing first-time cover crop use versus this long-term cover crop use.
Oh, very interesting.
We know that if you use especially these non-legume cover crops once or twice, and you get a lot of biomass, you'll get nitrogen immobilization. Like that's a given. But if you increase organic matter, will that change the cycling of carbon and nitrogen so that you get more nitrogen to your corn crop? And that's what we're going to be testing next. Not you know, my prediction is that it has changed in 15 years of cover cropping. I'm predicting it has changed. So we'll see.
And that image that you showed of that corn, I mean, it's, you know, in a number of years, it's pretty, I mean, it's pretty impressive.
It is.
And if I were, you know, watching that, I would say being consistent in my crop rotation and being consistent in adding a lot of living plants into my soil, even though it's hard some years, seems to be a good long-term investment in my yield potential.
Yes. Yep.
Yeah. Yeah.
Yeah. So the plant is telling us it's not getting enough nitrogen. Like I want to look at, you know, why is that? Is it more just that it didn't get enough water and therefore not enough nitrogen, or is it more about the cycling of organic matter and release and timing to that corn crop? And I had predicted it, but I didn't think we would see it so quickly. Like, relatively speaking, after 14 years isn't a huge amount. Well, it is huge, but it's not a lifetime, right, to see those changes. And I really think that combination of fresh plant residue with our grain stover, like our grain high C/N ratio, I think has a big influence on stabilizing soil organic matter, or at least that's my hypothesis.
Yeah.
And
you know, Laura, carry on.
Well, I don't know. It is a head scratcher, right? Like the paradigm has always been, okay, those crop residues, like, you know, whether it's straw or corn stover, you know, they just break down and release carbon dioxide. And that is true. I think with adding that green cover crops, it's kind of a synergistic effect. And so there has been some work in the literature that's tried to characterize that. And I think our experiment is set up well to test that in our system.
Okay. So to answer that question that person asked about what new things you're going to do in your study, it sounds like you're just going to look at the mechanisms a lot more carefully to try to actually understand. And that sounds like to me, a very worthwhile investment.
Yeah.
By the way, on that Sorry, go ahead.
Yeah, we have other
I
experiments.
was going to ask.
Go ahead, Martin. I want to hear your question.
Back to this. We have time. I was going to come back to this thing about the fresh material stabilizing the corn stover, or in our case, it might be, you know, a little bit of pea cover crop or red clover cover crop could stabilize the wheat stubble or the oat stubble, which means more of that carbon gets into the soil. One thing I've told my, you know, when I teach diploma organics, I ask somebody in the class who's feeding livestock, ruminant livestock, and we talk about rations for the livestock and, you know, what speeds up the rate of passage, what, you know, and it's actually, to me, it's always been the same process, right? If you feed the cow just a lot of carbon, you know, that cow is going to belch all that carbon back up. It's not going to actually get through the rumen. It's not going to produce milk. But if the animal has a balance of carbon and nitrogen, carbon and protein, then you get much better function. Would you agree with my analogy in your situation?
I think so. I think so.
Okay.
And I think we, yeah, what a great time to be thinking of these questions, to have the techniques available to ask these questions and
Yeah.
design experiments. But I think we,
Right.
yeah, I think that's a great analogy.
Well, thanks. That's great. Okay, we got another question here, and that regards the idea of, I think, free living nitrogen fixing organizations like asymbiote. Have you thought about, could you explain what that might be? You know, I want to make sure that our audience gets a good definition from you. And then what are your thoughts on its role in these cropping systems?
Yeah, so when we think of nitrogen fixing bacteria, I think for most people, we immediately think of legume plants and their association with nitrogen fixing. But there are microbes in the soil that, without that association with legumes, can fix nitrogen. And it's a huge research drive to, you know, the dream would be to have corn be able to fix its own nitrogen. And whether that's through an association with the bacteria, a microbe, it's a huge area of research. So that is precisely what the graduate student with Dr. Carrie Dunfield will be looking at, is the microbial community structure and their function. And so the reality is we don't know enough about all of the different, you know, species or the genes involved, but that's where they're looking. And that could be the mechanism, right? A healthy soil, increase organic matter, that biodiversity, it could definitely be a role.
Okay, thank you very much. I think, you know, people will stay tuned to that. A couple of more questions. Which tillage implement is most soil friendly? And I'm going to add an addendum. Does tillage speed also make a difference? Because we don't plow. Nope, there's no plowing on the prairies. It's basically a minimum till with sweeps, maybe some discs.
Yeah, I don't know. I'm gonna defer to your expertise in that. Does speed matter? Yes.
Well, you know,
Which is the best? I don't know.
Okay, next question. Which soil amendments, you had talked about amendments, would you recommend for organic grain production?
So livestock, that generated from livestock. So yeah, my personal opinion, if you're thinking about soil health, it's about carbon. So how much tons of carbon are you putting on your soil? Now, when you're talking about organic production, then you've got a whole bunch of other things to consider, like, can I apply it in the year that I'm going to grow the crop? What is the seed to end ratio, and when will we expect the nutrients to be released? Do I need to depend on that amendment for this year's crops nutrient release? But if I'm thinking just in terms of how do I build soil carbon, it's about tons of carbon that you put down.
And would composted animal manure be better than fresh in that regard?
So then it's about bulked, right? It's already bulked, and you've mixed that compost in with plant residues, and so now you are applying a lot more carbon to your soil.
Yeah, and I think there's been some, just to answer the question, there's quite a bit of European research on if you are going to add animal manures, composting them first does stabilize them and help in the soil health more than fresh manure. But composting is another step. So
yeah.
Okay. Yeah.
Yeah, I guess.
I think. Go ahead. I'm interested in your thoughts on this.
Well, it's about fresh versus dry and the nutrient density, right? And the carbon content. And yeah, some of those studies out of Europe, you have to, like, it's really challenging to set up those amendment comparisons because, it's hard to compare apples to apples.
Yeah.
But yeah.
I guess one of the I totally agree. I like the dock trial where they don't go in terms of tonnage of nutrients. They go, we have 3 animals per hectare.
Yeah.
And we're in the manure from that, either putting it on fresh or composting it and then putting it on. So that's that's a good study. That's a good comparison in my opinion.
Yeah.
Okay, I got a question. I think really, really important, and you did make reference to it, Laura, and this is an easy one. Is like you said, we should be monitoring our soil organic matter. How do we monitor it properly? Because a lot of farmers get their soil test back, it's got the organic matter level, and it jumps around quite a bit. And how should farmers be measuring their soil organic matter?
Yeah, so that is a common thing here in Ontario as well. So I would suggest one is make sure you're sampling to the correct depth. So 15 centimeter depth. Make sure you're getting a representative sample. So whatever that is for your field, right? Avoiding those extreme areas, like the headland or where it ponds. The other thing that's important in measuring soil organic matter is the method. So if you can try to stay with the same lab, because methods change, and if 2 different labs are using different methods, they could get different numbers. I think though the bottom line is if it is changing by 0.5% or what, like from 3.4 to 3.9, you'll see it. You'll see it in in how your soil feels, how it behaves, the ponding, all of those characteristics. And so those observations, the knowing of your land, that is valuable too.
Okay, thank you. Those are good, and those are good. That's good advice. I guess just further to that, should you also make sure that you're always sampling the same volume of soil, and accounting for the bulk density of the soil?
Yeah. So from a research perspective, if you're going to do that, or if you're going to talk about like carbon trading, then that gets important.
Yeah.
You know, I was thinking about, you've got a soil probe and you're going to the 15 centimeter depth. And
I like your advice. I think it's good. Yeah. Okay, there's one other. I think we're going to take one last question. We've had you here for a long time, but somebody just asked about biological primers. Do you have any thoughts on sort of these biological primers, or does the cover crop serve as the biological primer? So do you need a biological primer out of a jug, or do you grow it in your field?
Yeah.
I'm not being quite fair to the question that came in, but I'm trying to frame it for your cover crop work.
Right. So I guess if you're talking bugs in a jug, I would be cautious, and I would say, like, do test strips. Make sure that you document those test strips and take grain off of it. But we do know that if your field hasn't had pulses in it, that using a rhizobium is good, right? Like, and if you're adding soybean, then you want to use an inoculant, right? I'm not sure that question is talking about inoculants though, and biological fixation. So I think there is value in that, in inoculants. Bugs in the jugs, those are test on your farm. Yeah.
Okay, great. That's really good advice.
So if I go back to, where does that organic matter come from? It comes from plants. Like, maybe I'm biased because the microbiologist would say it comes from microbiology, but it's the capture of sunlight through photosynthesis that gives the soil carbon. And so if we think about it that way, how do I get plants on my field?
Right. I think that I would definitely agree with your answer, and I think what's really changed is research like yours has demonstrated, even though it's in a unique part of the world and maybe not exactly the same as here in the prairies, but I think it has clearly demonstrated the value of more plant diversity in different ways in the cropping system. And it seems to me that that's the low-hanging fruit in terms of making a system more productive. One of the questions that is here, another one came in. What about mixtures of cover crops? Like, you did mention your rye. You did talk about rye radish as kind of your consistent performer. That was interesting. I thought that was a really practical recommendation that you made. Any other sort of mixtures that might be useful? Any thoughts?
So we are measuring we have in a different trial. So after wheat, we're planting 1, 2, 4, 8, 12 species mix. We're looking at how much biomass do those mixtures produce, and then what ratios. And then we're looking at corn yield the next year. What we see in terms of above ground growth is it kind of plateaus, right? That's partly because of seeding rates. In terms of impact on corn, we don't have the data yet.
Okay.
Yeah. I think.
Thanks for that. It's pretty exciting times. I did plant on my little farm a mixture that I got, and it had it had turnips and sugar beets and millet and sorghum, and it was amazing how it grew, even though I planted it a bit later, and then when we did get some fall rain. So it is really exciting times for these cover crops.
Well,
Laura,
fun.
I am going to say it's fun. Yeah, that's right. And I think, people on the call had fun because none of them have left. Very few people have left. So that means that they've really seen you in this. Would you like to make some final comments before we let you get on with your day?
Yes. I guess it's fun, right? Growing cover crops is, right? You're a farmer, right? You enjoy growing a crop. There is, you don't have to worry about how much it's going to yield. If you set it up as a plan where before you even purchase your seed, how you're going to terminate it and what you're going to do with those crop residues whenever time that is. So if you have a plan, then it's nothing but fun. Watching those crops come up as opposed to weeds and worrying about what the weeds and how you're going to manage those weeds. And then seeing, oh, geez, well, the buckwheat was here, but now it's gone. And hey, now these cool season crops have taken over. Yeah, nothing but joy is there, or at least it's an opportunity. So I'll leave it there.
That's awesome. Thank you. On the note of joy and having fun, I love it. Laura, thank you. You have informed us in very wise ways. Your experience has been really valuable. I think we can see the application anywhere where we grow crops. We appreciate you taking your time and taking the time to prepare these slides and to present them in such an easy to digest way. And so we're all giving you applause, hands together, and I look forward to our future collaborations and keep the organic community in Manitoba and on the prairies in your mind when you think about new extension efforts. And so I wish you a fine afternoon, and we'll talk to you again, Laura. Take care.
Great. Thanks, Martin, for the opportunity. It's my pleasure.
Okay. Bye-bye.
Thank you so much. And I just also want to add to that, thanks to Dr. Entz for hosting as well and asking all the questions and moving us through this seminar. Thank you. That was a wonderful, wonderful seminar. And I was really feeling more excited about next year and planting some more cover crops and looking at my soil health next year. So we just want to go through some of the sponsors again of our webinar. So first of all, we want to thank the Canadian Agricultural Partnership who provided a grant to help fund the webinar. We've also received funds through the Prairie Organic Development Fund, and they've they're an innovative not-for-profit association providing vehicle to invest in development of prairie organic sectors. So we're very thankful for their additional funding. Thanks to the government of Manitoba through the Department of Agriculture, especially to Laura Telford, who's been instrumental in arranging the webinars as well. To FCC, Farm Credit Canada. In addition, we have we've been sponsored by grain millers. Check out their website, grainmillers.com, for more information about their programs, particularly on oats and flax. I think they're looking for oats and flax growers. Manitoba Harvest is looking for hemp growers. So if you're interested in growing organic hemp, give them a call. They've got their number, and you can go online and get their details there as well. ProCert, an organic certifier body. They're based out of both Saskatchewan and they've got an office in Ontario as well. So they're across Canada, and they are doing both the organic and regenerative organic certification. And finally, we have Theory Mesh, who's an agricultural supply chain traceability app, and they're delivering increased transparency and efficiency. So thank you again for tuning in today. It was our second webinar. We're skipping a week next week. We're actually I'm going to be at the Manitoba Forage and Grassland Association conference, and we're going to be working together with them on producing a website that I'll be demonstrating there. We're just still in the building stages, but we're going to be linking up organic grain farmers and livestock producers, first of all, across Manitoba, to see if we can integrate livestock on more cropping land. So I'll be at the Manitoba Forage and Grassland Association conference next week. And our next webinar will be on the 23rd of November. It will be about legumes for nitrogen supply, again, under water limited conditions, which we all still are until possibly tomorrow, when we might have our first snowstorm. So thank you again to everyone for joining us. Thanks to Martin and Laura for leading us in this great discussion. We'll see you on the 23rd.